Okay, so this video we're going to talk about the percentage by mass. It is an extension to what we have learned before. However, in the textbook you can't find any sections talking about that, okay, but actually it is a further applications of percentage by mass. And also you can mix the skills of like calculation based on equation to help you to do such kind of question. So what is these questions about, okay? So first of all, you will find that, okay, the questions, they will tell you something like maybe we got a seashell here. Okay, if you know that, okay, we know that inside the seashells we contain calcium carbonate, and then they're going to react with the HCl. We put acid in it, okay, and then we expect that they will give up some salts, carbon dioxide, and water. If the mass of the seashell is given like 10 gram, then we will expect a certain gram, let's say X gram of carbon dioxide will be given out. However, after doing the experiment, like previous videos that we've talked about, maybe the gram that we obtain from the seashells, the carbon dioxide mass obtained, it may be less than the theoretical mass of carbon dioxide obtained. The actual value will be smaller than the theoretical value. One of the reasons is because inside the seashells, they may contain some impurity. Not necessarily 10 gram of the seashell is the calcium carbonate. It may contain like 8 gram calcium carbonate. For the rest, maybe other kind of substances. So we're going to have a mathematical ways to present how much calcium carbonate inside the seashell is going to react. Okay, so have a look of the percentage by mass, okay, of a chemical. That actually it means that inside the sample they will contain more than one chemical, while some other chemicals have no reaction in the process. For example, in this case, okay, calcium carbonate, okay, it will be the one have active reactions, okay. However, if it have like calcium carbonate and together with some, for example, calcium chloride inside the seashell, then in this part, okay, the calcium chloride will have no reaction with the hydrochloric acid. So therefore, in this process, you will find that even 10 gram of seashells, only part of them they will react to give the carbon dioxide. So the assumption right here will be the assumption, very important, okay, we assume the impurity has no reaction with the other chemicals, okay, so we assume the calcium chloride here have no reaction with other chemicals, okay. So the mass of sample actually involves two parts. One is the reacting chemical, in this case it will be the calcium carbonate, while the other part will be the non-reacting chemical. Those are the impurities, okay. So for the equation, how can you write that? It will express like this way. The percentage by mass, okay, it will be mass of the reacting chemical over the total mass, okay, times 100%. For example, we'll just use the previous one as an example. Percentage by mass of calcium carbonate in seashell. Then the mass of calcium carbonate will be the denominator, while the total mass, it will be the mass of seashell. So if we say like 8 gram, okay, inside 10 gram of the shell, then the percentage by mass will be 80%. Okay, so you have to know that in most cases, the percentage by mass have to be less than 100%. Okay, let's have the first example. So for these questions, okay, you'll find that, okay, we have silver coin with mass of 12 gram dissolved completely in corn nitric acid to give silver nitrate solution. At this moment, you may think that, oh, silver have no reaction with the acid, okay, but right now we're having corn nitric acid. So later on, you'll learn that they will have reaction. So you'll find that all the Ag will react with corn nitric acid, and then they give out silver ion, okay. When excess potassium chloride solution was added to the resulting solutions, okay, so 14.4 gram of white precipitate will be obtained. So you learned this before, okay, if we have silver ion, chloride ion, they react to give silver chloride, which is solid, okay, white precipitate. So this one, okay, we know that we have like 14.4 gram, okay, so you have two ways to do that, okay. The first one, okay, related to the calculation based on equation, okay, we can first find out the number of mole. Okay, we have this equation, okay, we have the data, okay, we're going to find out how many gram of silver do we have, okay. So first of all, we're going to find out the number of mole of silver chloride first, Okay, so that will be 14.4 over 107.9 plus 35.5 gram. So this one, okay, you have like 0.100 mole. Okay, we can see that, okay, the ratio right here, okay, will be 1 to 1. Okay, so therefore the number of mole of Ag will then be Ag or Ag plus it will be fine. Okay, so it will be 0.1 divided by 1 times 1. So it will be 0.100 mole. So for the mass of Ag, that will be 0.1 times 107.9. Okay, so the answer for this one would be, will be 10.79 gram. Okay, so after that, okay, what you need to do is to find out the percentage by mass. Given is 12 gram, so this 12 gram, it must include the impurity. So we are not using this 12 gram to do the math. Okay, so remember this 12 gram is fake. Okay, so now we have the percentage by mass of silver in the con. It will then equals to 10.79 over 12. Okay, because that is the one above is the mass of silver. This one is the total mass. Okay, and then we time 100%. So the answer for this one will be 89.9%. Okay, so this is the first way, method 1, okay, to do it. Okay, with another method to do that. Okay, so we can have a look. Okay, so if you know that, okay, the white precipitate, it will be silver chloride, right? So it will be like 14.4 gram. Actually, we can find out the mass of silver in silver chloride, right? Okay, actually this silver, okay, from silver chloride, actually all this silver is coming from the silver coin. So we can have the molar mass of silver over molar mass of silver plus chloride times the total mass. So what we have like 107.9 over 107.9 plus 35.5 times 14.4 gram. So by doing this, okay, we can also find that, okay, the mass of it will equals to 10.79 gram. Okay, so we'll find that, okay, if 10.79 gram is coming from the silver chloride, and we use this one, okay, to do the second part of the calculation. We have the mass of the silver over the mass of the silver coin, which is 12 gram. Okay, and then times 100%. We can also find the percentage by mass of silver in the coin. Okay, so both method 1 or method 2, okay, both of them is okay. Okay, see which one you feel comfortable to do that. Oh, second one, okay. Now we have 8.9 gram of impure sample. So this one is a fake one. Don't use this one to do mass over molar mass. Okay, so we have silver oxide and then heat strongly. So we have like silver oxide. 8.9 gram is fake one. So I put bracket for that. Okay, and then they could hit. Okay, so they will form silver and oxygen here. So to balance the equation, okay, you got something like this. And then from the question is saying that, okay, we have 7.75 gram of silver obtained. So this one is correct one due to the experiments, okay? So we're going to find out the percentage by mass of silver oxide in the sample. So we're going to find the real mass of it, okay, real mass of it, okay, and then find out the percentage by mass, okay? So by doing this, okay, we can find out the number of mole of silver first. So we have 7.75 over 107.9. Okay, and then you got 0.0718 mole. And then, okay, the number of mole of Ag2O would then be 0.0718 first divided by 4, then times 2. Okay, so divided by 4 times 2, so you got 0.0359 mole. Okay, so the mass of it, mass of Ag2O would then be 0.0359 times 107.9 times 2 plus 16. Okay, so the mass for this one will then be 8.324 gram. Okay, and then finally you're going to find out the percentage by mass. Okay, percentage by mass will then be 8.324 over the total mass of the sample. Total mass is 8.9. Okay, so we're going to have 100%. So the answer for this one would be 93.5%. Okay. Well, last examples. Okay, we're going to paint pigment. Okay, have 1.5 gram. It dissolved and lead to iron and it separate by precipitation. Lead to sulfate. So this one, okay, we're going to find a precipitate. Okay, has a mass of 0.0849 gram. That means this is the mass of PbSO4. Okay, PbSO4, right? Okay, so what is the percentage by mass of lead in the pigment? That means this 1.5 gram is not all of them are lead. Okay, some of them are lead plus other impurities. Okay, so we assume this impurity have no reaction with the sulfate, so therefore they won't form some precipitate out. Okay, so the equation that we have will be Pb react with the sulfate ion, and then they form lead to sulfate. So this one is a solid. Okay, maybe at this moment, okay, you don't really know the equation how to write. Okay, but this is a precipitations. Okay, just like silver ion with the chloride ion. Okay, so this one, okay, we find out, okay, the mass of it will be 0.0849 gram. Okay, so you can find out the mass of it, the mass of lead, because we want to know how much Pb we have, okay, inside this 1.5 gram of the paint pigment. Okay, so you have two ways to do. First of all, you can find out the number of mole of PbSO4, and then you can find the number of mole of Pb, and then you can find the mass of Pb. So this is method 1. Method 2, okay, you can find out the Pb in the Pb lead to sulfate. Okay, so we use the method 1 first. Okay, so we have like lead. Okay, PbSO4 would then be 0.0849 over with 207.9 plus 207.2. Okay, plus 32.1 plus 16 times 4. So will equal to 0.000280. Okay, mole for that. Okay, and then for the number of mole of Pb will then be the same. Okay, it will divide it by 1 times 1. Okay, so it will be like this one. Wow, so many 0. And then for the mass of the Pb, mass of Pb will then be equals to 0.000280 times 207.2. So the answer for this part will be 0.0580. Okay, so percentage by mass. Then we're using this mass over the original 1.5. Okay, so I'm 100% for that. It will equals to 3.87%. Okay. Hopefully I didn't do the math wrong. So this will how we're going to do the percentage by mass. Okay, but actually you got another way, a little bit faster. Okay, again you can use the Pb in SO4. So you're going to find Pb in SO4. We will then be having the mass of this one times 207.2 over 207.2 plus 32.1 plus 16.4. You shouldn't do like that way. You shouldn't write like this way. Okay, you have to be on the same row. Okay, but I don't have enough space. Okay, but anyway, so by doing this, okay, you will find that, okay, the mass of it will be 0.0580 gram. Okay, so it will be equal to this one, and then you can follow the rest of the procedures. Okay, but I just want to say that, okay, you can also use the percentage. You can use Pb in SO4. Okay, this way, okay, find the mass in the sample. We can also use calculation based on the equation, like the sections. Okay, the calculation based on the equation, you can use these sections. Okay, to find out the mass of Pb. Okay, both method actually is the same. Okay, it seems that you write a lot of things right here. Okay, but if you get used to it, actually use the calculator, you can do all the math. Okay, so both is correct. Okay, so see which method you prefer. Okay, So finally, in conclusions, okay, you know that, okay, some of the sample they may contain some impurities, and these impurities most of the time they are unreacting, or we assume they do not react with other chemicals. Okay, so not necessarily all the sample can react completely. So you'll find that the actual value of the product will be less than theoretical values. Okay, so we're going to find out, okay, how much of the samples are really the sample that we're talking about. So we'll have like the reacting chemical inside the sample mass. Okay, we'll have a term called percentage by mass to do it. Okay, so the mass of the reacting chemicals, okay, over the total mass, okay, times 100%. Normally the percentage by mass will be less than 100%. Okay, so that's all for this video. Bye bye.